Good morning, students. In this section, we will discuss about input impedance of a transmission line when it is terminated with any load. That means simply we are deriving a small expression for input impedance. To derive this expression, we need two basic equations. That is, in our previous section, we have already discussed regarding to general solution of the transmission line. Those two equations we have to consider like this. These are the two equations, general equations. This is the one equation and this is another equation. These two equations we have to consider now. So by considering these equations, we can be written as, we know that the general solution of a transmission line are, the first equation is V equal to Vs cos h gamma x minus Is z naught sin h gamma x, and I equal to Is cos h gamma x minus Vs by z naught sin h gamma x. These are the two equations we have derived in our previous section. Now with these two equations we are deriving the corresponding input impedance. Now I am writing it is equation 1 and it is equation 2, and in this case I am considering a transmission line, a simple transmission line like this. It is the simple transmission line. This time drawing here with a load. It is terminated with a load called ZL is the load, and here it is the input section. So I am assuming the input voltage is Vs, that means voltage at source Vs, and current at source is Is. It is the load. So I am assuming the voltage across this load is Vr, and current in this load is IR. I am assuming those parameters like that, and at the same time I am assuming the length of the transmission line is L. L is the length of the transmission line. That means here when we assume it is the total length x equal to L, the value of x is 0 at this point, the value of x is L at this point. So I am assuming this transmission line. With this transmission line, I am assuming, that is from the figure at x equal to L, that means at this point the value of voltage and currents are V is equal to Vr and I equal to IR. Those are the voltage and currents at this point. Now I am substituting these two values, that means at a x equal to L and V equal to Vr, I equal to IR in equation 1 and 2. In these two equations I am substituting these two values. So by substituting there, first thing here V is nothing but Vr equal to Vs as usual, Vs cos h gamma x is nothing but L, gamma L minus Is z naught sin h gamma L, and here I is nothing but IR is equal to Is as usual, Is cos h gamma L minus Vs by z naught sin h gamma L. So I have substituted all these values. that is x equal to L substituted, V equal to VR substituted, I equal to IR substituted. Those three parameters are substituted here. Now at x equal to L, the expression for voltage, that is VR at x equal to L, VR can be written as at x equal to L, VR equal to ZL into IR. It is the general formula. When we consider a general formula, V is equal to IR. Here I is nothing but IR and R is nothing but load ZL. So we are equal to ZL into IR. ZL into IR. So now I am substituting this VR value here and this IR value here. I am substituting those two values here. Then by substituting, the first thing VR value is this. So Vs cos H gamma L minus Is Z naught sin H gamma L is equal to ZL into IR is nothing but this one, ZL into Is cos H gamma L minus Vs by Z naught sin H gamma L. I have substituted the values of VR and IR. Now in the next step, just simply multiplying here those two values, and with these values now I am letting this Z naught from this side, that means as a common. So as usual expression, Vs cos H gamma L minus Is Z naught sin H gamma L equal to, I am taking Z naught as a common, so ZL by Z naught into, here there is no Z naught term to get a common, so just I am multiplying here Z naught. So Z naught will get cancelled and the rest of the same term will be having here. So, Z naught into Is cos H gamma L minus Z naught is out, Vs sin H gamma L. Now I am taking this Z naught to this side. Here it is a division. When it comes to this side, it will become multiplication. So Z naught into Vs cos H gamma L minus Is Z naught sin H gamma L equal to ZL into Z naught Is cos H gamma L minus Vs sin H gamma L, the same values. Now I am multiplying. Here I am multiplying with Z naught to internally and ZL to internally. Just those two terms I am multiplying internally. So by multiplying here Z naught into this term, so Vs Z naught cos H gamma L minus Is Z naught into Z naught square sin H gamma L is equal to this one, Z naught ZL Is cos H gamma L minus Vs into ZL, Vs ZL sin H gamma L. Now I am taking Vs terms to one side and Is terms to another side. By letting, just I am keeping this Vs as usual here. I am keeping here Vs Z naught cos H gamma L, and here it is the Vs term. I am taking to the side. Here it is minus. When it comes to this side, it will become plus Vs ZL sin H gamma L equal to this term as usual, Z naught ZL Is cos H gamma L. Here it is minus, it will comes to this side, plus is z0 square sin h gamma L. Now I am taking this Vs as a common term at this side. Vs into z0 cos h gamma L plus zl sin h gamma L equal to, in this side I am taking is z0 as a common term. Is z0 common, it will become zl cos h gamma L plus z0 sin h gamma L. Now here I am letting this is to this side and the multiplication of this term to this side. So it will become Vs by is is equal to z0 into zl cos h gamma L plus z0 sin h gamma L by z0 cos h gamma L plus zl sin h gamma L. It is the expression. Here Vs by s can be written as z in or zs. Simply zs equal to, this is the expression. That is, now it will become z in equal to or zs equal to z0 into zl cos h gamma L plus z0 sin h gamma L by z0 cos h gamma L plus zl sin h gamma L. It is the generalized expression for input impedance. Generalized expression for input impedance. Now for example, when we want to simplify this expression, then consider just simply zs equal to z0 into, take cos h gamma L as a common term from the numerator and denominator. So cos h gamma L as a common term from this, then here is zl plus z0 sin h gamma L by cos h gamma L by, from the denominator also, cos h gamma L, z0 is the only term at this point, plus zl by zl into sin h gamma L by cos h gamma L. Here this one get cancelled, then zs equal to z0 into zl plus z0 sin by cos, that is tan h gamma L by z0 plus zl tan h gamma L. It is the simplified expression, and in our derivation points of view we can use this one or this one. This is the expression for input impedance of a transmission line when it is terminated with any load.